Assalamu alaikum. In this present lecture of the physics course of 9702, I'm beginning or solving the very first question from Unit 3 Dynamics. This question is taken from November 2024 past paper variant 2.1, and this is question number 2. As you can see, the very first part A of this question is about to define linear momentum. The command word is define here. Define linear momentum. Two lines are being given, one mark is being given here. It does have a very standard answer. Whenever it is being asked, you have to answer that the product of mass and velocity. Yes, the product of the mass of the object and the velocity of the object will be called, will be regarded as, will be named as a quantity momentum. So many quantities are being defined by simply multiplying the two quantities. As an example, right now, we are multiplying mass and velocity and getting an answer of momentum. Already, you know, in case of turning effect of forces, we have multiplied force and perpendicular distance and obtained a new quantity called moment, M-O-M-E-N-T, or the turning effect. So many new quantities are being defined by simply multiplying the two already defined quantities. So many times we have defined the new quantity by simply dividing one in the numerator and one in the denominator, like you did in case of distance covered. Sorry, like you did in case of speed or velocity, which was the displacement divided by time in case of velocity. Similarly, in acceleration, you did change in velocity divided by time. So, this is the normal standard procedure in physics that we are defining or we will be being defining the new quantities by multiplying already present two quantities or by dividing the two already present quantities. After that, the next part is a car of mass 1800 kilogram is moving in a straight line. Figure 2.1 shows the variation with time t of the momentum small p of the car. As you can see that this graph is about momentum against time, momentum on the y-axis. Its unit is not being missed here. Its unit is definitely being written here. Newton into seconds, Newton multiplied with seconds, while time is on the x-axis and time is also given in seconds. So this is called the momentum against time graph. As you can see, from 0 seconds time up to the 8 second, the graph, the momentum on the y-axis increases uniformly in a uniform manner with a uniform gradient. The momentum is increased by a straight line graph. And then after the 8 second, it falls or decreases once again by a straight line graph. Your examiner is saying, calculate the maximum speed reached by the car. What will be the maximum speed? So maximum speed can be obtained, students, by using the maximum momentum. So I have used the maximum momentum, and for that purpose, I have drawn that line so that I can obtain the exact value from the y-axis. This line must be parallel to x-axis from the top of the straight line given graph. So mass has been given as 1800 kilogram. It remained constant. So it is not playing any role in the maximum value of momentum or in the minimum value of momentum because it is fixed, it is constant. Yes, at that point, the maximum velocity actually, or the maximum speed actually, is playing its role in giving us the maximum value of momentum. So as we know, the value of momentum at this particular point, at the stop point of the graph, will be equals to this one, which is obtained as 7.2 into 10 raised to the power 4. 7.2 into 10 raised to the power 4 will be the value of momentum, obviously in Newton into seconds. 1800 is the mass. And speed of the moving object can be obtained from here. Speed of the moving object can be obtained by using the maximum value. The maximum speed of the object can be obtained by using the maximum value of the momentum. So the maximum value of speed can be obtained from here, which will be equals to 40 meter per second. After that, the next part is calculate the maximum kinetic energy of the car. The maximum kinetic energy of the car can be obtained by using the maximum speed, which was equals to 40. So if you will apply half into 1800 into 40 into 40, the formula of kinetic energy, as we all know, equals to half mv square. So in place of mass, you have to put the value of 1800 kilograms or 1800. So half into 1800. And as far as the v square is concerned, you have to put the value of 40 square, or I'm saying 40 into 40. So in this way, you'll obtain the maximum value of kinetic energy, which will be obtained as an answer given here. 1.4 into 10 raised to the power 8 joules. Half 1800 into 40 square is obtained as. Then students, we have reached to the third part of this question, in which examiner is asked about show that the acceleration of the car at time t equals to 4 seconds is 5 meters per second square. As you can see, the momentum is increasing in the first 8 seconds. It definitely means that the velocity is increasing because mass remained constant. Mass of the car remained constant. And the value of the speed must be increasing, and the increase of speed must be called acceleration. So that acceleration is required at time t equals to 4 seconds. At time t equals to 4 seconds, the value of acceleration is required. So I have drawn a straight line parallel to y-axis from the 4 second, move to the graph. Then I have drawn a line parallel to x-axis and touch the y-axis at this particular value. This value is being noticed from here, and this value can be used in our calculation. As you can see that the force, the definition of force is the rate of change of momentum. I have an idea that I want to calculate the value of acceleration from F equals to ma. Mass is given, acceleration is required. So first of all, we need to calculate the value of force. And force is the rate of change of momentum as is being written in this formula. Mass remained equals to 1800. It is going to multiply it with the maximum value or maximum velocity. So it gives us the answer equals to v minus u over t stands for, as you can see, that we are interested here. Uh, this is the 4 second, and I have noticed in the 4 second, the value of the momentum is equals to 3.6 into 10 raised to the power 4. In the 0th second or in the beginning, the value of momentum can be taken as 0. So mv stands for the final momentum, mu stands for the initial momentum. So I have substituted the final momentum of the 4 second equals to 3.6 into 10 raised to the power 4. The value is taken from the graph, minus initial momentum, which is equals to 0 when the stopwatch is being started. And overall, the value of momentum changed from 0 to 3.6 into 10 raised to the power 4 Newton into second in 4 seconds. So it is being solved, and the value of force obtained as 9.0 into 10 raised to the power 3 newtons. This value is being substituted here in A equals to F over m. By dividing it with 1800, we'll prove that the value of acceleration in the 4 second is equals to 5.0 meters per second square. Then examiner is saying determine the distance traveled by the car during times t equal to 0 and time t equals to 12 seconds. What is the distance traveled? The total distance traveled, starting from time equals to 0 seconds and ending at time equals to 12 seconds. So total distance traveled is required. I have applied, as the given graph is made up of two stages. Stage 1 from 0 to 8 seconds, in which the value of momentum is increased, and then the stage 2 from 8 second to the 12th second, and the value of momentum is uniformly decreased. So you can see that stage 1 distance covered will be taken as S1, stage 2 distance covered will be taken as S2, and the sum of S1 plus S2 will give us the total distance covered. So for S1, what I did, ut plus half AD square as the initial velocity for stage 1. Stage 1 started from 0th second when the stopwatch is being started and ended at 8th second. So for ut, I have multiplied 0 with time of total time of 8 seconds because the initial speed was 0 here. So 0 multiplied a car was at rest. Car was at rest. Initially, it was being given somewhere in the question. The car was at rest. A car of mass this much, or also it can be obtained as the momentum was 0 when the stopwatch is being started. So it means the speed of the car was 0 there. And if the speed of the car was 0 there, it means it was at rest. It hasn't covered any distance because its speed was equals to 0. So 0 plus half 80 square, as we have just proved during the first 4 seconds, during the first 4 seconds, the value of acceleration was equals to 5. And as the speed was increasing uniformly, it means it was the case of uniform acceleration. And remember, my child, the equations v equals to u plus 80, s equals to ut plus half 80 square, and the third one, v square minus u square equals to 2 times of a into distance covered, 2as. All these three equations can only be applied if the object, if the car is moving with uniform acceleration, and car is moving with uniform acceleration in the present case. It can be proved from so many different evidences in this question. So I have taken the acceleration equals to 5, which was in the 4th second, and it remained up till 8th second. The same acceleration remained as the acceleration of the moving car from 0th to 8th second. Total time was 8 seconds, so I have taken the square of 8. Similarly, for distance S2, which is actually, in case of which the initial speed should be taken from 8 second and the ending speed should be taken from 12 second. And as we know, the object once again is coming towards rest, so its final speed is 0 this time. But initial speed was being calculated by us in part 1 as 40. So here you can see for ut, we have taken it 40 into time of 4 seconds plus half. So as it is the case of deacceleration or retardation, as the velocity is decreasing. Clearly from the graph, you can see that the velocity is decreasing. So this is the case of deacceleration. So I have taken the value of acceleration as minus, as negative. From where this 10 is obtained, I have used here the formula of acceleration A equals to V minus U over T. And from here, I have obtained the value minus 10. I have substituted this value minus 10 here. And here the time is equals to 4, so 4 square. And finally, I have obtained the value of S1 equals to 160 meters, S2 as 80 meters, and by adding these two, I have obtained the value of total distance covered S, which was required for the whole journey of 12 seconds, equals to 240 meters. Then we come to part C. On figure 2.2, sketch the variation with time t of the acceleration A of the car in B from time equal to 0 to time equals to 12 seconds. As I have already told you, Bacho, students, I have already told you that from 0th second to the 8th second, the acceleration remained uniform or remained constant, equal to the value of 5 meter per second square. So you can see a straight line parallel to x-axis at a value of plus 5, because acceleration is positive here. And then suddenly in the 8th second, the value changes from plus 5 meter per second square to minus 10 meter per second square for the next 12 seconds. The sudden change in the value, there's a sudden change in the value, as you can see, which was being indicated by the graph of the car, the momentum against time graph of the car. So I have drawn this graph here. That's all. This question is finally being solved.